Hey everyone, and welcome. So today, we're diving into something I think every developer is thinking about. How do we get AI to be more than just a code vending machine? Moving past just typing in a prompt and getting a chunk of code back, and toward something more, a real partner.
You hit the nail on the head, Clara. It's really about building an AI collaborator that thinks smart, that gets what we're trying to do, and this is the big one, that gives us code we can actually trust. And we've got some incredible research to look at today, from frameworks like Dream and Tenet to new training approaches like RA3 and IFIM, and even some really mind-bending stuff on verified reasoning.
And that's really the big question we're tackling, right? I mean, we all know AI can spit out code like crazy. It's fast. But can it actually partner with us? Can it get ahead of our needs and think through a really thorny problem? Well, today we're going to look at some amazing research that's trying to make that answer a definite yes. All right, so let's jump right in. First up, this massive challenge, making AI think smarter, not just harder. Because let's be honest, right now, a lot of AI problem solving feels like brute force. It's just throwing everything at the wall and seeing what sticks.
That is a perfect way to put it. It's super expensive in terms of computer power, and it's just not elegant. But the good news is, new methods are totally changing the game, making the AI's whole thinking process a lot more structured and, honestly, a lot more like how we think.
So the key idea here is to just break the problem down. There's this paper on a framework called Dream, and it introduces this really powerful model, plan and execute. The best analogy is a chef. A great chef doesn't just start throwing ingredients in a pan. Nope. First, they write down the recipe, that's the plan, then they follow it step by step, that's the execute. By splitting it up like this, the AI can look at its own plan and say, wait, this recipe is terrible, before it wastes a ton of time and energy cooking a bad meal. And here's where it gets really brilliant. Dream isn't just about planning and then executing. It's also about being smart with its resources. So if a step in the plan is super easy, it can solve it quickly and, well, it saves that leftover brain power, that computational budget for the really tough parts of the problem later on. This makes for this incredible balance of accuracy and efficiency, and it just blows standard methods out of the water on tricky logic puzzles and math problems. Okay, that is a huge leap in efficiency. I love it. But it makes you wonder. As a developer, I don't solve every single problem from the ground up. I see a problem and I'm like, oh, I've seen this pattern before. I have these reusable skills in my toolkit. So the big question is, can we teach an AI to do that? You're thinking exactly along the right lines. That's the core concept in a paper on something called RA3. Basically, they train the model to sift through tons and tons of code and spot these common, high-level patterns. A classic example, if you've ever dealt with linked list problems, you know that a super common trick is to create a dummy head node to simplify things. RA3 learns to see this not as individual lines of code, but as a single reusable skill. So the next time it encounters a linked list problem, it doesn't have to reinvent the wheel. It just pulls out its dummy head skill and is already halfway there. And the data totally backs this up. I mean, look at the performance boost. This idea of learning abstract skills gives it a major leg up. On standard coding benchmarks like HumanEval, the models using RA3 jump up by an average of 8 points over the basic models. That's a huge deal. It just goes to show that teaching an AI to think in patterns, just like we do, makes it a way more powerful problem solver. Okay, so the AI is a smarter thinker. That's awesome. But we all know that the best engineers aren't just lone geniuses, right? They're incredible collaborators. And that brings us to our next big piece of the puzzle. How do we teach an AI to actually understand us, to work with us, and fit right into how we already do things? And I am sure everyone listening has felt this pain. You're using a coding assistant. You leave this super helpful, crystal clear comment, something like, hashtag now filter out all the negative numbers. You think, great, it'll get the hint. And then it just completely ignores you and does something totally different. It's so frustrating. It's like, can you not even read what I just wrote? So that exact frustration is what a paper on something called IFIM is all about. And the reason AI assistants ignore our comments is actually pretty simple. They were never trained to pay attention to them. The standard way, called fill in the middle, just teaches a model to look at the code before and the code after and guess what goes in the middle. This new method, IFIM, or instruction-aware fill in the middle, is a game changer. It changes the training process to explicitly tell the model, hey, see that comment? That's an instruction. It's important. Use it. And would you look at the difference it makes? It's absolutely dramatic. On a benchmark that tests this exact skill, the models trained this new IFIM way saw their get it right on the first try score jump from around 84% to almost 94%. That is a massive leap in reliability. And all it took was teaching the model to actually listen to us. Amazing. Okay, so comments are one thing, but collaboration is way more than just comments, right? It's about our whole process. And a huge part of modern development is test-driven development, or TDD. There's this paper on a framework called Tenet that looks at how we can use tests as another way to collaborate with AI. Because think about it, a test isn't just a check at the end. It's a perfect, runnable, crystal clear way of telling the AI, this is exactly what I want you to build. And this is where it gets really interesting, and honestly a bit counterintuitive. You'd think, okay, more tests must be better, right? I'll just give the AI everything. But the Tenet study found that's not true at all. The sweet spot, the optimal number, is actually just 3 to 5 really good diverse test cases. If you give it more than that, the performance actually starts to go down. It's a classic case of quality over quantity. A few perfect examples guide the AI better than a fire hose of information. All right, so we've got an AI that thinks smarter and works with us better. That's great. But if we want it to keep getting better, we have to level up the challenges we give it. We can't just keep throwing the same old simple function completion tests at it. We need new benchmarks that are way tougher and way more like the real world. And that's exactly what a benchmark like IWR Bench does. The task is wild. The AI watches a screen recording of someone using a website, and its job is to recreate that website, buttons, forms, everything, from scratch. And the results are so telling. You can see this huge gap. The AI is pretty good at making a screenshot, basically. The visual fidelity is okay, but making the thing actually work, making the buttons click and the forms submit, the functional correctness score just falls through the floor. It's a massive blind spot for today's models. And that struggle isn't just with websites. It's with core programming concepts, too. Check out these results from the multi-OOP benchmark, which tests complex object-oriented code. With GPT-4o Mini in Python, it does okay, almost 50%, respectable. But look what happens when you switch languages. C++, it drops to 15%. And Java, oh my gosh, it's less than 1%. It's this insane performance cliff that shows these models might know Python, but they don't truly understand programming in a way that transfers easily. Which brings us to what might be the single most important part of this whole conversation. Because we can have an AI that's brilliant, that's a great collaborator, and that aces all these tough tests. But if we can't trust what it produces, none of it matters. So let's talk about how we build the trust engine. This is probably one of the weirdest and most important findings I've come across lately. It's from a paper on something called VAPO, and it deals with models that can see, these vision language models. And it found this totally bizarre paradox. The longer a model thinks about an image, the more likely it is to forget what's actually in the image. They call it visual forgetting. It's this crazy idea that more thinking can actually make the answer worse. And VAPO is just such a clever fix for this problem. What it does is force the model to stay grounded in what it sees. As it's thinking step by step, VAPO injects these little anchors, simple factual statements about the image, like the bus is yellow. The model then has to check if that anchor is true. It's like a pilot who, during a long flight, is forced to constantly look down and check their instruments. It keeps the model tethered to reality and stops it from just drifting off into a hallucination. Okay, that is a fantastic way to stop the model from forgetting what it's looking at. But it brings up one last massive trust issue. What if the model is perfectly grounded, but its chain of logic is just broken, you know? How do we know its reasoning is sound? It's exactly like that high school math teacher who would always say, great, you got the right answer, but you get 0 points if you don't show your work. We need to see the work. And that right there is the holy grail. And what's so exciting is that researchers are now building systems to do exactly that. They act like an automated fact checker for the AI's entire thought process. The system takes the AI's natural language reasoning, translates it into cold, hard, formal logic, and then uses automated tools to check if every single step is mathematically valid. It's a way to automatically sniff out bad logic or hallucinations and give us something close to a real guarantee of trust. So let's just take a step back and look at the whole picture we've painted. It's really been a journey, hasn't it? We started with the foundation, making the AI a more efficient thinker with ideas like Dream and RA3. Then we built on that, teaching it to collaborate and understand our context with IFIM and Tenet. We made it stronger by testing it against really tough, real-world challenges like IWR Bench and multi-OOP.
And then we added the most important layer of all, trust, using techniques like VAPO and verified reasoning. Every single one of these is a crucial building block.
It really does create a complete picture. None of this stuff is happening in a vacuum. All these different threads of research are starting to weave together, and what's emerging is a totally new way to think about building software. It's a future where it's not human versus AI, but a genuine human-AI partnership where we both play to our strengths. I really believe we are right on the edge of that new era. And so that leaves us with the final, biggest question of all. This idea of an AI engineer isn't some far-off sci-fi dream anymore. It's being built, right now, piece by piece. So the real question for all of us is, once it's here, what are we going to build together? Thanks so much for joining us today.
Thanks for listening, everyone. We'll catch you on the next one.